Alright, Math 1. Today we're talking about compound inequalities. And we're going to be using a lot of what we know about inequalities to help us solve compound inequalities. Your essential questions are, can you use addition, subtraction, multiplication, and division to solve inequalities? Can you graph the solution of a compound inequality? And can you write and solve a compound inequality that represents a real-world problem? So first, what is a compound inequality? It is formed by joining two inequalities with the words and or. So a compound inequality uses the words and or. When a compound inequality uses the word and, it means that the numbers that satisfy both inequalities so it's one and the other. When it uses or, it's numbers that satisfy one inequality or the other. So it can be and when we have an and compound inequality, the answer or the solution set is all the numbers that satisfy both parts. And when we have an or compound inequality, our inequality solution set only has to satisfy one part of the inequality. So let's take a look at this next piece. If we were to graph x is greater than or equal to 2, we would have a closed dot on the 2 and we would be going to the right. If we were to graph x is less than 5, we'd have an open dot going to the left. And if we had 2 is less than or equal to x, and x is less than 5, we have a closed dot on the 2, an open dot on the 5, x is less than 5, and if you wanted to rewrite this, x is greater than or equal to 2, so it's easy to see which direction our line's going. These are the only solutions that satisfy both parts. It can only be the numbers that are in this little bitty section. On the other hand, if we have an or, y is less than or equal to, that's a closed dot to the left. Y is greater than 1. If we have y is less than or equal to -2, or y is greater than 1. The or equations are nothing in here, but everything less than -2 and everything greater than 1. So you can see the difference between an and equation and an or equation, or an and inequality and an or inequality, just by looking at them for the most part. So let's take a look at the word sentence. A number x is greater than 8, or -8, and less than or equal to 4. And we have an and here. So we need to go from -8 to 4. And it looks like we have open dot and greater, and we have a closed dot and less than, and they meet in the middle. Alright, a number y is at most 0, so y is less than or equal to 0, or, I might highlight that this is an or problem, y is at least 7, so greater than or equal to 7. So 0, and 7. Y is less than or equal to 0. Y is greater than or equal to 7. Alright, go ahead and try the next two, numbers 3 and 4, for homework assignment. And then we're going to try solving some compound inequalities without graphing. So, anytime you see a compound inequality with two inequalities in it, see, here's one inequality and here's the second one. This is an and inequality. They're always ands. So when we solve them, it's kind of like having two equal signs. We have to do whatever we're going to do to get x by itself on all three locations now. So when we subtract 1 to get rid of it, I have to do it on both sides of my inequalities. So I get -4 is less than -2x is less than or equal to 9. I mean 8. 9 minus 1 is 8. And then we divide by -2. Now when we divide by a negative, that flips our inequalities. So I get 2 is greater than x is greater than or equal to -4. And we don't have to graph that. We just have to write it. Alright, let's take a look at the next one. I would subtract 9 from all three spots. 6 is greater than -3x is greater than or equal to -9. Divide by -3. -2. I divided by a negative, so my sign flips. -2 is less than x, which is less than or equal to 6. Okay, I'm going to let you try that one for homework. Now we have some or inequalities, and we just solve them as two separate inequalities. So add 5, 3x is less than negative 3. Divide by 3, x is less than negative 1. Or, and I need to keep that or there, add 1, 2x is greater than 6. Divide by 2, x is greater than 3 would be my solution. So the or inequalities written with the or word have to have or in the answer. Go ahead and try those two for homework. Okay, so let's take a look at solving an absolute value inequality. When we're solving an absolute value inequality, we know that we have two separate answers every time. So we know that the absolute value could be, the x value could be 2 or negative 2, and that would make this answer come out correctly. So knowing that, when you just have a simple absolute value of x is less than 2, x could be less than 2. And then if I fill in a negative here, I have to flip my sign because I'm filling in a negative. So x could be greater than negative 2. And if I fill in numbers for those x's, for example, what a number greater than negative 2 might be 0. If I fill in 0 here, 0 is less than 2. X is less than 2, a number less than 2, again 0. 0 is less than 2. So it will work every time. So now the distance between x and 0 is less than 2. To graph that, I'm going to have x is greater than negative 2, so I have an open dot on the negative 2, and that would be going to the right for greater than. X is less than 2 would be an open dot on the 2 going to the left for less than. So all of the numbers in between negative 2 and 2 satisfy my absolute value inequality. Anything less than negative 2 or anything greater than 2 does not satisfy my absolute value inequality. So let's take a look at the second one. This time we have absolute value of x is greater than 2. So x is greater than 2. I just write down that simple one. But I always know with an absolute value equation I have two possible answers. So x is less than negative 2. On this one, I'm going to have things come out a little bit differently. So if I go to graph them, x is greater than 2 goes to the right. X is less than 2 goes to the left. So now my solution set is nothing that goes in between them, but everything that goes to the right and to the left of my two possible inequalities. Let's take a look at a few more absolute value inequalities. X plus 7 is less than or equal to 2. So I know x plus 7 is less than or equal to 2. And then I also know that x plus 7 is greater than or equal to negative 2. So you'll notice when I do my two options for my inequalities, for my absolute value inequalities, when I do the negative one, it flips my sign. Make sure you're flipping your sign whenever you do the negative one. So now we just solve these like two regular inequalities. Subtract 7. So x is less than or equal to negative 5. Subtract 7 here. X is greater than or equal to negative 9. Those are my two inequalities. Take a look at the next one. So 8x minus 11 is less than 0. Now we have an interesting situation because I can't have a negative 0. 8x minus 11 is greater than 0. I'm just going to have them both ways, but when I do that, if I add 11 and get 8x is less than 11, divide by 8, x is less than 11/8, and here I would add 11 and then divide by 8, x is greater than 11/8. I cannot have an answer that's both less than and greater than 11/8. So here I would have no solution because it's not possible to have it both ways. And on the next set, again, we just would subtract 1. Remember, we have to get our absolute value by itself before we can set up our two equations. Divide by 4. So now I know that 2x minus 5 is greater than 7, and 2x minus 5 is less than negative 7. I would add 5. 2x is greater than 12. Divide by 2, so x is greater than 6. Add 5 over here. 2x is less than negative 2, so x is less than negative 1. X is greater than 6 and x is less than negative 1. Okay, I will ask you to try this last one for homework, and when we get to class tomorrow, we'll go over the 2 absolute value word problems, but I do want you to try 1, 2, and 3 on the very back page. Go ahead and try those for homework as well. Have a great night.